Hey, what's up?
Go on in. So, should we start? We have to finish our calculus project.
Man, screw that. I'm gonna play some Pokemon.
I'll finna join you.
Fine. So, what start are you guys gonna choose?
I'll choose quadratic.
I guess I'll choose trigonometric.
And I'll choose Taylor polynomial.
To find our quadratic approximation, first we'll start with the general form of the quadratic formula, which is y equals a quantity x minus h squared plus k. Using our h and k, which is the vertex of our cake, and then using a test point, we'll find that a value. It comes out to y equals negative 0.455 quantity x minus 7.62 squared plus 6.604. To find the area, we use that y, and then we use the times dx, and we use the limits of integration 3.81, 11.43. Those are our x-intercepts. Our area comes out to 33.546 centimeters squared. Volume, we use that y times 2 pi x. This is cylindrical cells method. We use the same limits of integration, and our volume comes out to 1,606.12 centimeters cubed.
Darn it, man.
I haven't even come across a Pokemon. Oh wait, there's one. To find the sinusoidal function, first we'll start with the general form of the sinusoidal, which is y equals a sine quantity b times the quantity x minus h plus k, where a is our amplitude, b is our period, h is horizontal shift, and k is vertical shift. First, we'll plug in the amplitude, which is our maximum height, then we'll plug in a 0 to solve for b. Once b is found, we'll plug in a, b, and h for the general function. Now to find our area, we'll use our limits of integration, which are our x-intercepts 3.81 and 11.43. Using these limits of integration, we find our area to be 32.0582 centimeters squared. Now to find our volume, we'll use cylindrical shell method, where we multiply our function by 2 pi x. And using the same limits of integration, we find our volume to be 1,535.4 centimeters cubed. This game's hella rigged.
Wait, let me try. We start off our polynomial with a standard form of a normal distribution curve, or Gaussian, e to the negative x minus a squared over 2b squared, all over the square root of 2 pi b squared, where a is the mean and b is the standard deviation. We shifted the graph down to create two x-intercepts. We chose our a value by making it the x-coordinate of the vertex, and chose our b value by determining the distance between the two x-intercepts. We finally performed a vertical stretch to get the right height. We were left with e to the negative x minus 7.62 squared over 2 times 1.485 squared, all over square root of 2 pi times 1.485 squared, minus 0.01 times 6.604 over 0.25865. From there, we use the Taylor polynomial for e to the x to manipulate and find e to the negative x squared, where x equals x minus a over the square root of 2 times b. From there, we find our Taylor series to be 1 minus x minus 7.62 over square root of 2 times 1.485 quantity squared, plus x minus 7.62 over square root of 2 times 1.485 to the fourth, all over 2 factorial, minus x minus 7.62 over square root of 2 times 1.485 quantity to the 6th all over 3 factorial, and we carried this to the 22nd degree. Now that we have our equation, we solved for our area by integrating between our x-intercepts, which yielded 23.32 centimeters squared, which makes sense due to the concavity of the curve. Finally, we used cylindrical shells to find the volume, yielding 1,116.71 centimeters cubed. This game is impossible! It's almost like they wanted this to be a group project.
Good idea, guys. Let's team up.
Hey guys, looks like we're coming up on a gym.
Oh no! This gym has the hardest trainer of them all!
Who? Psh, Mr. Golub?
Worse, Mr. Fashion.
For our final attack, we start with the gamma function. Also called the continuous factorial function, its general form is gamma of z equals the integral from 0 to infinity x to the z minus 1 power times e to the negative x dx.
Using various transformations like reflection, horizontal shift, and horizontal stretch, we manipulated the gamma function to fit our Calc's values. The new function is y of z equals 5.604 minus gamma z minus 3.85 over 2, or if we really want to say it, 5.604 minus the integral of 0 to infinity x to the power of z minus 3.85 over 2 minus 1 times e to the power of negative x dx.
What a mouthful. Using a numerical integrator, the area of the Calc cross-section is 28.0231 centimeters squared. Using cylindrical shells, we multiply y of z times 2 pi z integrated from the z-intercepts, and voila! 1,279.19 centimeters cubed.
Guys, we did it!
We should probably start on our calculus project. It's due tomorrow.
Wait, guys. I brought Zelda.
Darn it, man! Ugh!
Hey, what starter are you guys gonna choose?
What starter am I doing?